Hello, I am Cesar from Masters College, and in today's video, I'm going to show you how to do an interesting data sufficiency exercise. We're going to start by reading the question. Set A is a finite number of positive consecutive multiples of 26. How many elements of A are multiples of 39? Statement number 1, set A has 15 elements. Statement number 2, the smallest integer contained in set A is a multiple of 39. Next, we're going to analyze what it takes for a number to be considered a multiple of 39. In order to do that, I'm going to obtain the prime factorization of that. 39 is the multiplication of 3 and 13. In other words, for a number to be considered a multiple of 39, it must contain at least one factor of 3 and one factor of 13. Because the main statement is telling us that all of our elements are multiples of 26, then all of the elements of our set will contain at least one factor of 2 and one factor of 13. In other words, the condition of the factor of 13 is already satisfied. I'm going to rephrase what I said. All elements of set A contain at least one factor of 13, so we just need to count the elements of our set that contain one factor of 3. Using that idea, we can rephrase our main question this way. How many elements of set A are multiples of 3? In order to save some time, we need to be aware of a certain number property that says, in a group of 3 consecutive integers, there is exactly one multiple of 3. First, I'm going to start by getting a representation of what my set A will look like. I can represent set A this way. 26 multiplying a certain positive integer k. The next consecutive multiple of 26 will look like 26 times k plus 1, then 26 times k plus 2, 26 times k plus 3, 26 times k plus 4, and I'm going to represent until 26 times k plus 5. Then I'm going to separate them in groups of 3. The first group that I have contains integers k plus 1, and k plus 2, which are 3 consecutive integers. So I will definitely know that exactly one of them is a multiple of 3. On the next group of 3, I also have 3 consecutive integers, k plus 3, k plus 4, and k plus 5. So exactly, I know that one of them is a multiple of 3. That will let me get a conclusion for statement number 1. It says that set A has 15 elements. If my set A has 15 elements, it has 5 groups of 3 like the ones that I'm highlighting here. It means that on each group of 3, we will have one multiple of 3. Consequently, the answer to our main question will be 5. Statement number 1 is sufficient. Statement number 2 tells me that the smallest integer contained in set A is a multiple of 39. In other words, the first element here, 26 times k, is a multiple of 39. K must be a multiple of 3. On the next group of 3, my multiple of 3 will have the same relative position. It will also be the first of the group. So 26 times k plus 3 is also a multiple of 3. Consequently, a multiple of 39. But the problem with the statement number 2 is that it doesn't tell you the total number of elements into our set. So we will not be able to determine how many groups of 3 elements we have in total. Consequently, the number of multiples of 39 is uncertain. Then the conclusion for statement number 2 is that it is not sufficient. Now that we have already obtained a conclusion for our 2 statements, we can start looking for the right answer choice to our question. This is how the answers for data sufficiency questions look like. Because first we found that statement number 1 was sufficient, that will allow me to eliminate answer choices B, C, and E. That information combined with the fact that statement number 2 is not sufficient will let me eliminate answer choice D. Consequently, the right answer for our question is A. Statement number 1 alone is sufficient, but statement number 2 alone is not sufficient. Thank you.